Guys, the question number 11 is again about the escape velocity of a planet. You've been given the escape velocity of a planet, which is VE. A tunnel is dug along the diameter of the planet and a small body is dropped into it at the surface. Now you have to tell what speed it will attain when it reaches the center of the planet. And now?
Okay. See, this is another energy balance. So in this I'll begin with whatever we know. Initial kinetic energy
Right.
plus potential energy should be equal to the final kinetic energy plus potential energy. Okay.
Simple energy conservation.
Yep, simple energy conservation. So in the beginning they are given that the ball is dropped. Okay. So the initial kinetic energy would be 0 because the velocity would be 0 as it is dropped.
Right.
So I'll write it down. Minus g m upon r square. It is at the surface of r, so we can use any formula.
Correct.
Oops, it will be r over here. Minus g m upon r is equal to minus g m upon 3r square minus r square upon 2r cube plus half mv square, where v is the final velocity. Okay. So now I'll simplify it. Minus g m upon r plus this r is 0 over here because they've asked us at the center of the earth, center of the planet. Okay. So this would be equal to 0 because the radius would be 0.
Yeah.
Plus 3 upon 2 g m upon r is equal to half mv square. So m would get cancelled off and this would come out to be gm upon 2r is equal to half v square, where v is the final velocity, so 2 would also cancel off. Okay. So now we have found the velocity in terms of gm upon r. So therefore we have to find it in terms of escape velocity. So for that escape velocity हमें पता है that half into m into v escape square is equal to potential energy at that point.
Right.
So gm upon r. तो इससे हमारा v escape आ जाएगा. This will come out to be under root 2 gm upon r.
Correct.
Okay. तो इसको अंडर रूट लेने की जरूरत नहीं है वैसे. Upon 2 is equal to gm upon r. Okay. And we'll replace this quantity over here. So gm upon r is equal to v escape square upon 2. So this will be the whole thing. So v final would be equal to v upon under root 2. So this is what the answer is. Option number B.
Right.
Yep. तो इसमें the only thing is that energy balance ठीक से लिखना है. काफ़ी बार होता है कि हम इसको यहाँ पे लिख देते हैं, इसको यहाँ पे लिख देते हैं. So what I would suggest is कि पहले write this down and then एक एक करके substitute करो. Will never go wrong. Don't try to do it orally. Okay. Follow step by step.
Okay, that makes sense. We'll move on to the next question now. Now let's quickly solve question number 12. For a satellite of mass m orbiting around Earth, which has mass capital M and radius capital R, having net energy minus g capital M small m divided by 20r, find. Now there are 4 parts of this question. You have to find 4 things. A. Velocity of the particle. B. Distance from surface of Earth. C. Time period. And D. Angular momentum of the satellite. Arnav?
Okay, so we'll begin by writing down the energy. And I've given the energy as minus g m upon 20r. Okay, so we'll use the previous relation, that is energy is equal to u by 2 and energy is equal to minus of kinetic energy.
Correct.
Okay, we know these two relations. So using these we can find the potential energy and the kinetic energy. And once we find the potential energy, we can find the radius, and once we find the kinetic energy, we can find the velocity. So this is the thought process that we have to employ at the beginning of the question.
Correct.
So let's begin. Minus g m upon 20r will be equal to minus g m upon 2 into x, where x is the radius. So therefore 2x comes out to be 20r and x would be equal to 10r. So therefore हमारा distance from the center of the planet, or इसमें as in this case Earth, center से distance would be 10r.
Yeah.
So this is the first information that we have. Now second information is with the kinetic energy. So therefore half into m v square would be equal to g m upon 20r.
Right.
So therefore velocity would be equal to under root g m upon 10r. तो इससे हमारा velocity आ गया और distance from the center आ गया.
Correct.
So this is actually a very elegant way of doing it. अगर आप करते हैं कि total energy is equal to kinetic energy plus potential energy, and इसमें kinetic energy को फिर potential energy के terms में लिखते हैं v square upon r वगैरह use करके, तो बहुत लंबा बहुत complicated हो जाता. This is a very easy way of doing it. So now velocity of particle is equal, this is the a part, gm upon 10r, distance from surface of earth. So surface of earth में this is 10r, so b option would be 10r minus r equal to 9r. Take care of this, okay? Many a times they'll ask you the distance from the surface, many a times they'll ask you the distance from the center, so that गलती मत करना. Now the third part, which is equal to time period. Let me just check it. Yep, time period. So basic formula use करो. Don't try to mug up a lot of things. 2 pi upon omega. Omega is equal to v upon r. So if you use all these things, you don't need to remember a lot of things.
Correct.
So इसको लिख दो 2 pi. Velocity is equal to 10r upon gm, and radius is equal to 10r. So it will come inside into 100 r square because it will get squared while coming inside. So this would be 2 pi under root 1000 r cube upon gm. So this would be our C option. Now the fourth option is angular momentum. So I'll write it down. Angular momentum is equal to m v r. तो मास हमें पता है m. Velocity is equivalent to under root gm upon 10r. And radius is equal to 10r. This would come out to be m into under root gm 10 gm into r. This would be our final answer.
Okay guys, we'll move on to the question number 13 now. Who don't Now guys, in the question number 13, we have a certain double star system where two stars rotate in circular orbits about their common center of mass. These stars are spherical and they have the same density rho, and their radii are r and 2r. Their centers are placed 5r apart. Now you have to find the time period of the rotation of these stars. Arnav?
Okay. See, the question seems a little tricky. थोड़ा समझ में नहीं आता starting में क्या करना है. So I'll begin. सबसे पहले तो mass different है दोनों का, because the radii are different and the density is same. सबसे पहले हम mass निकाल लेंगे m1 and m2. Let me draw the diagram first. This is the first r, and they are placed 5r apart, and this is the second sphere. इसका radius is 2r. Sorry for the diagram, but ठीक है. Let me call it m1 and let me call it m2. ठीक है. So now we know rho is equal to mass per upon volume. So therefore m1 would be equal to rho into 4 upon 3 pi r cube.
Right.
Okay. And m2 would be equal to rho into 4 upon 3 pi into 2 cube. That is 16.
Correct. 8.
Sorry, 8. 2 cube is 8. My bad. 8 r cube. So this comes out to be 8 m1. So now we know the masses. तो अभी इसके बाद क्या करें क्वेश्चन में? रोटेट अबाउट द कॉमन सेंटर ऑफ मास. तो सेंटर ऑफ मास के लिए वी नीड रेडियस ऑफ रोटेशन. तो रेडियस के लिए हमें सेंटर ऑफ मास का डिस्टेंस निकालना पड़ेगा फ्रॉम ईच एंड एवरी स्टार, ताकि हमारा रेडियस आ जाए और उसके बाद वी कैन पुट इन द इक्वेशंस. तो लेट मी पुट दिस एज अ कोऑर्डिनेट एक्सिस एक्स वाई. सो द सेंटर ऑफ मास के लिए इट वुड बी 0 into m1 plus 5r into m2 upon the total mass, that is m1 plus m2.
Correct.
Now we know that m2 is equal to 8 m1. So I would suggest कि don't put in the values every time. Use this relation ताकि easy रहे थोड़ा सा calculate करने में. तो 8 into 5 40 m1 upon m1, that is 8m plus m 9m. So this would come out to be 40 upon.
Won't it be 40 m1 r upon 9 m1?
No, it won't be. Oopsie, m1 r. So it would be 40 upon 9 r.
Yeah.
So this would be the distance from the coordinate axis. This is taken as the origin, okay? So this would be the distance. So now we have the center. Okay, we have the center, we have got this distance, and we have to find the time period.
Correct.
So अभी इसके बाद we'll use the centripetal force वाला equation. mv square upon r is equal to force, the universal equation. So force in this case would be only due to the gravitational force.
Correct.
So I'll write it down. M पता है हमें, it is equal to, we'll find it for m1, okay? The beginning we'll find it for m1. So m1 into velocity is unknown, okay? We have to find velocity, and r is 40r into 9 is
Can we
equal
call
to
it v1 for mass 1?
Okay, v1. So this would be equal to g m upon r square, m1 m2. So m2 is equal to 8m. So let me call it as gm m1 square upon r. R over 5r, that is 25r square.
Yeah.
Fine. So now we'll have to solve this equation. So m1 v1 square, v1 square into 9 into m1 upon 40 is equal to 8 g m1 square upon 25.
Right.
I'll cancel off a little bit. So v comes out to be g m1 into 64 upon 5 into 9 r. Because this thing will get cancelled off. There will be 5 over here, 8 over here, 8 into 8, 64, 5 into 9.
Correct.
So this would be and this m would get cancelled off. So this is the velocity that we have found. Now the time period would be 2 pi upon v into r. I'll directly write it down. So 2 pi into velocity is equal to 5 into 9 into r upon g m1 into 64 into the radius over here would be the distance from the center of rotation. So this will come out to be 40r upon 9. So therefore finally aa jayega 2 pi into under root 40 here. So this 9 would get cancelled off. R cube into 40 into 40 into 5 upon g m1 into 64 into 9.
Right.
So finally सब कट कुटा के and हाँ इसमें again we have to change the unit of, you have to change this m into 4 upon 3 pi r cube. Yeah. Because the answer has to be given in terms of r and rho and g, not in terms of m1.
Exactly. So the variables that you have been given in the question, always use them for answering the question.
Yeah. So I'll just write down the final answer. It will come out to be 5 into 5 pi upon 3 rho into capital G. We'll write a small m as 4 upon 3 pi r cube. So r will get cancelled off, and then this 3 will go on the top, and you'll get this answer. Like this will get cancelled off. You'll have to solve it on your own. So this is the time period that we have. Now the thing is that whenever the system is such that there is a center and there are two of them rotating, the time period for both of them will always be the same. So you don't need to calculate the time period for the second one and then find the answer. The time period of the second one would also be the same. The velocity would be different, the radius would be different, but when you divide velocity upon radius, that is omega, the angular velocity would be same for both of them.
Okay.
So this is the solution.
Okay, so that's an important information we have learned here.
Yep.
We'll move on to the next question now. So guys, in question number 14, we have two stars, each of mass m and radius r, and they're approaching each other for a head-on collision. They start approaching when the separation is small r, which is much more than the radii, which is r, capital R. If the speeds at this separation are negligible, what will be the speed with which they'll collide? Arnav?
Okay, see, this is a very simple question. It is again of energy conservation. So I'll write down the energy conservation formula. That is the initial kinetic energy plus potential energy should be equal to the final kinetic energy plus potential energy.
Right.
Okay, so initially the kinetic energy is 0 because they are given us that the speeds are negligible.
Right.
And potential energy will be minus g small m upon r. It should actually be small r plus small r plus capital R, like this plus 2 into capital R. But because small r is very very big compared to r, we neglect this. Okay.
Correct.
So finally it will be the kinetic. I'll write down the potential energy first, minus g m square upon 2 into capital R, because when they'll be in contact, they'll have a distance of 2r between them, plus half.
Can you show us in the diagram?
Okay, I'll show it to you. This is the first one and this is the second one. So these are the two objects. The distance will be 2r.
Correct.
Okay, and the kinetic energy would be half mv square plus half mv square. Because see, once they'll collide, so both of them will have independent kinetic energies, whereas the gravitational potential energy would be same for them. Gravitational potential energy is for any two objects, it's not for one object. So when I write that this is the gravitational potential energy for these two objects. So this would be the formula. So now it becomes pretty simple, I believe. So half mv square into 2 So minus g m square upon r plus g m square upon 2r is equal to mv square. Velocity would be equal to under root gm 1 upon 2r plus 1 upon r. Sorry, minus, because this minus symbol is over here. These are the kind of mistakes that you might also do in the exam, so take care of them. Okay, so this is the answer, and this is option number B. I'll show the 4 options first. These are the 3 options, and this is the 4th option. So this is what
correct.
It is.
So guys, if you don't pay attention to the correct sign convention, you might end up
getting an incorrect answer,
which could be D in this case. Yeah.
They'll give you options such as this, which if you do something wrong, you will get that. And another thing which needs to be thought of is that the kinetic energies have to be added, because think of it physically, both of them would have kinetic energies, so we'll have to add half mv square twice.
Yeah, because the whole of potential energy was converted into both of their kinetic energies and both of their potential energies. Right, so simple energy conservation again, guys. We'll move on to the next question now. So guys, question number 15 is really interesting one. Imagine the distance between the Earth and the Sun were half its present value. What would the number of days in a year have been?
Okay, this is another question, satellite motion basically. And this will begin with the uniform circular motions equation. mv square upon r is equivalent to gmm upon r square. This is the force, this is the mv square upon r. The force should be equivalent to this.
Right.
So using this, we'll get the formula of velocity, the expression for velocity, gmm upon r. This r, both of the r's are same, it is equivalent only. It does not make any difference. R is the distance between the two objects, that is the sun and the earth in this case. So therefore we get the expression for velocity. Now again we'll have the expression for time period, 2 pi upon v into r. This is all very repetitive, but this is what JEE people ask. Most of the questions are based on satellites and the motions and the time periods only. So hence it is very important that you remember all these things, and at the cost of repetition also, but still do follow these steps. Don't directly jump to the conclusion. Okay, 2 pi under root r cube into gm. So therefore the time period is equal to 2 pi upon under root gm into r to the power of 3 upon 2. Fine.
Correct.
So right now the distance between the present value would have reduced. Okay. So the r becomes r by 2, or initially let us take the r to be 2r. Okay. Initially 2r, finally r. Fine. So we'll find the time period initially is 365 days. And 365 is equal to gmm upon blah 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 into 2r to the power of 3 upon 2, and finally t is equal to 2 pi upon.
So basically we're assuming that the initial distance was 2r, not r.
Yeah, because we have to reduce it, so we have to divide this.
Sure.
So 365 upon t would be 2 to the power of 3 upon 2, because r would get cancelled off.
Right.
Fine. Now again we have to approximate it. This is what JEE people ask. They'll give you a simple equation, put the values in, and then approximate it.
Right.
So 2 to the power of 3 upon 2. So this would come out to be 2 root 2. Okay.
Yeah.
So root 2 is around 1.4. Okay. So I can take it to be approximately 3 upon 2, 1.5. So I'll write that down. 2 into 3 upon 2. Okay. Now the thing which has to be noted is that the actual value of this is less than this.
Exactly.
Therefore the whole thing should be more than this.
More than this. Yeah.
So a little greater than this thing. So it will come out to be this. This comes out to be 121.2 something. Okay. This comes out to be 121 point something. Okay. So now we'll have to look at the options. Let us look at the options. 64, obviously this is the incorrect one. 730 is also incorrect, so it is between this and this. So what did we figure out? That the whole value has to be greater than the value that we get.
Right.
So we are getting 121, but the closest answer is 129. So this is only the correct option. So again, approximations play a very important role.
Okay, that makes sense. We'll move on to the next question now.